What's up, everybody? We are back with another Leetcode problem number 2033. This is quite interesting problem. Actually, the thing is that it is quite, I would say, yeah, it is quite confusing to come up with a better solution of it. The brute force solution is quite simple for this problem. So let's begin with the problem first. Minimum operation to make a uni-value grid. Okay, the thing is that the problem is so simple. You are given with a grid, right? That is 2, 4, 6, 8. Okay, it is the grid. The thing is that you have to make each and every value, each and every value equal to each other. Like if you want to make each and every value 2, you can make it by just adding or subtracting any value. Okay, the value can be of infinite number of time you can perform a operation. Like for an example, let's give a chance to see example first. So let's understand the problem using the example. Okay, the grid is given like 2, 4, 6 and 8. Okay, the x is 2. It is given that x is 2. Okay, so you can add or subtract infinite number of time, the infinite number of times from this value. Okay, so basically the thing is that you have to make every single element in the grid the same. Okay, x can be added or subtracted any number of times from the number. Okay? The thing is that you have to return minimum number of operations. So basically it is a minimization problem. So it is you have to perform the operations in a matrix, and the operations can be anything. It you can subtract or add to the number. Okay, for the better approach, you have to first and foremost you have to flatten up this whole matrix. Like flatten, after flattening you can just get 2, 4, 6, 8. Okay, after this you have to arrange this whole array. Okay, you have to sort this whole array. After sorting this whole array, we can apply our operation like prefix sum. To solve this problem, you need to have some idea about the prefix sum. Okay, it is much more better way to understand this problem by simply coding it up first, and then we can move on with the explanation also. So first and foremost, let me comment some lines. First operation will be we have to check if we can make each and every element the same or not. We have to check it first that can we make this element same or not. Okay, so check. The first step will be the checking. The next step we have to flatten it up and arrange the whole array. Flatten and arrange. Okay, so after that we have to follow the step of the prefix sum. Okay, so basically first and foremost how we can check this thing, like it is given x is equal to 2. We will divide each and every element by 2 and find out the remainder. Like the first element 2, 2 divided by 2, the remainder will be 0. 4 divided by 2, again the remainder will be 0. 6 divided by 2, again the remainder will be 0. 8 divided by 2, again the remainder will be 0. So in each and every case we can see that the remainder is same, that is 0. Okay, so we can make each and every element the same. We can make it the same. Okay, by just addition or subtraction we can make these elements same. So this is how we have to check whether the element can be made similar or not. If the remainder is totally different, we cannot make it similar. Okay, so basically the first step is checking. We will write the code for it. for R in grid, that is, we are first traversing the rows for C in R, if C percentage of X not is equal to grid, we will take any of the value. We can divide it with 2, 4, or 6 or 8. You can take any of the elements. You can take over here 0 of 0, that is 2. Here over here the 2. You can also take 4 also, not problem. You can also take 4. No, for my code, I will be just accepting the first element. You can take any of the element, and that's not an issue. So basically, not percentage of X. So if the remainders, if the remainders are not same, that is, we cannot make it similar. So we will immediately return -1. Okay, -1. Okay, we will immediately return -1. Else we can continue with our operations. First and foremost, we have to flatten up the whole matrix. For flattening, nums is equal to that is for R in range, for R in grid for C in R, that is C. Okay, for C in R. Now after flattening it up, we have to sort the whole array. Okay, so nums dot sort. So okay, nice. Nums dot sort. Now we have to perform the main operation, that is the prefix sum. Actually, if you solve the prefix sum, it will be much more easier to understand this problem. So let's declare some variable first. Prefix is equal to 0, where we will store the all the prefix sum. Total total is equal to, sorry, we have 0. Total, it will store the sum of the complete array. Assume sum of nums nums. So it is a minimization problem. So for minimization problem, we have to declare the result to infinite. That is, we have to declare the result with maximum value. So res is equal to float of nth. Now we have to traverse through the uh, array for I in range. Len of nums. Now we have to calculate the total cost of the left part and the right part. For calculating the total cost of the left part, the operation will be COS, cost L is equal to nums of I, nums, that is the current number that we are in, nums of I into the index number, into, where is, into I, minus the prefix sum. So it will give you the total cost till now uh, at the left part, and we have to also calculate the total cost at the right part, for the right part also. So cost underscore R is equal to total minus prefix minus nums nums of I into len of nums minus I. So this is we are calculating the cost for the rightmost part. That is, it is the total sum minus prefix, the current prefix sum minus the current element into the difference of the total length of the array minus the current index. It will give you the cost that is corresponds to the rightmost part of the array. Okay, so basically we are almost done with the solution. Now we have to calculate. Okay. Let's calculate the result first. Res is equal to the result will be the cost adding the summation of the cost of the both of the part, that is cost of the left and the cost of the right, that is cost of the left and the cost of the right, and dividing it with the x that is given over here, that is 2. Okay, so basically we have to do the summation first. Cost L plus cost underscore R divided by, that is we are dividing the integer division we are going with, so x that is given over here, so x. Okay, so after that it is the actually number of operations, op operation. Have we declared this variable op? It is the number of operations. Let's comment it out, else it will be confusing very much. So number of operations we are calculating over here, number of operations, and after that it is a minimization problem, so we have to find the minimum, right? Res is equal to min of res comma op. Okay, the number of operations. So basically we are almost done. So after that, after updating the result, we have to also update the prefix sum over here. We have to calculate the prefix sum for at the end of that iteration. So basically prefix plus is equal to nums of I, okay, and return res, then return result. Okay, so let's run the code up first. Okay, it is completely fine. So let's submit this problem. Mm, let's see how it performs. It's quite respectable. It's quite okay. Let's analyze the complexity also. We can O of n log n. The brute force approach was O of n into m whole square. So it is quite good as compared to that. So basically, this is all about the most efficient code. So this is all about the code, and I will be back with another Leetcode problem next day. So this is all about the solution.